Hi, we're going to work an ANOVA problem using Rguroo. Here's the question. You have just been promoted to sales manager of a company that manufactures robots used to assemble automobiles. Although your sales force is given a suggested price at which to sell the robots, they have considerable leeway in negotiating the final price. Past sales records indicate that sometimes there is a large difference in the selling prices that different sales reps are able to negotiate. You are interested in knowing if this difference is significant, possibly because of a more effective negotiating strategy or exceptional interpersonal skills, or whether this observed difference in the selling prices is just due to random variation. You decide to randomly select 4 sales over the last year for each of your 3 sales representatives and observe the actual selling prices of the robots. The table below shows the amounts at which the robots sold in thousands of dollars. Okay, that was quite a bit to read. Let's go back. And you can see here that we're interested in knowing if there's a difference in the 3 sales representatives. And if I read further here, I can see the 3 sales people's sales. Now, again, if it says 10, that's 10,000. So all of these are in thousands of dollars. So you can see salesperson 1, 2, and 3 here, 3 columns of data, and they're 4 randomly selected weeks. Now, you also can read underneath it says, based on the results of your survey, can you conclude that there is a significant difference in the average selling prices that the 3 sales reps have been able to negotiate? So, again, that word difference shows up in this question that is considerably long, but it shows up again in this difference in the average selling prices. So, I'm looking there and seeing that word average, which is just a really casual way to say mean. So a difference in the mean prices. And the other thing that stands out to me is that we have 3 sales reps. So not just the difference in 2 different salespersons, but 3. So once we get to 3 or more, the way we test a difference in means is with an ANOVA test. So the first thing we're going to want to do is write down the hypothesis statements. So here is our null, and it simply states that mean 1 is equal to mean 2, or the mean for salespersons 2, which is equal to the mean for salespersons 3. So the null hypothesis assumes equality among the means, that they're all considered the same. In the alternative hypothesis in ANOVA test, and this one's written out as a sort of a sentence fragment rather than symbols, it says at least one mean is different. So either they're all the same or at least one is different from the rest. There we go. All right, so we have our hypothesis statements here. We know we're testing an ANOVA. So the thing I'd like to do next is show you how to do this in Rguroo. It'll save you a ton of time because quite honestly, the hand calculations for testing an ANOVA or doing an ANOVA test is quite lengthy and complex. So I am welcoming using software for this question. So here is our Rguroo. I just opened it up. This is just a data table that's there when you open it up. And if you're working one of these questions in Hawks, you will hit the copy data button in your certify assignments. And I'm going to come here to this first row, first column, and I'm going to do Control V. And this is traditionally how it's going to paste in. It's going to paste in exactly the way you see it there in Hawks. So we have 3 columns, salesperson 1, salesperson 2, salesperson 3, and then the sales we saw from the prior slide. So I need to work with this data a little bit before Rguroo can analyze it for me. So most of the time taken to do this will be with just doing some data steps to make this look better. And then the analysis itself takes just a few clicks as well. So the first thing I'm going to do is I'm going to rename these columns to, I'm going to call it S1 for salesperson 1, just not feeling like typing a lot today. And rename the second one to S2. And then the third to S3 for salesperson 3. Okay, and now I'm going to remove this row. I do not need the row here with the row titles that ended up in an actual data row, not the up at the top. So I will remove this row, delete it. Okay, and now before I do my next thing, I want to make sure about my data types, because when things come in sometimes with the titles that end up in the first row, it confuses Rguroo. So I'm going to go to this variable properties button that you've probably seen at this point in the semester. And you can, when I click on S1, you can see it's calling it nominal, or another word for kind of a description of it being a categorical variable. And that's because the words came in with it. When we look at S1, we know it's quantitative. These are tens of thousands of dollars. So I'm going to have to change it back in all three of these, as you can see, and S3, to be understood as numerical. That's the first small change we need to make. All right. The next thing I need to do is for Rguroo to understand the data, I need to reform this data, reshape it, let's say. And instead of having three separate columns for salesperson 1, salesperson 2, and salesperson 3, I need to put them in one single column. All these numbers, these 12 numbers here, need to be in a single column. Now, I could either retype them, copy and paste them. There's lots of ways to do this. I'm going to use one of Rguroo's feature under the data panel here. And I'm going to come to the right and go to functions. Click here. And I'm going to choose reshape. And actually, before I do that, it's going to force me to save this. That's one of the things I always forget with Rguroo. I need to save this. Let's call it sales robot, something like that. Great. So we always have to save it. Now let's go back as where I was, over here. Let's go to reshape. And we're going to go wide to long, which means I consider the data set right now wide. It has 3 columns. I prefer this to be long, which is one column with all 12 numbers in them. So this is going to keep it on the default wide to long here. If I choose all the way down here, sales robot, you can see S1, S2, and S3 have shown up. So I'm going to click, and I'm going to hold my control key down and highlight all 3 of them and advance them over. So I've just grabbed the 3 I have, and I'm going to give my, it says ID variable. I'm going to put salesperson here. I think I spelled that right. And that's going to be the name of a new variable that's going to pop up here when I click the preview. Okay, so let's see what happened here. So you can see now the 12 numbers are vertical. They're long instead of wide now. And next to each of them is a reminder of where they came from. So these first 4 numbers are from salesperson 1. You know, the second 4 numbers are from salesperson's 3 and or 2, and so forth. So we've now made the data set long. And this is the way Rguroo needs it in order to do an ANOVA test. So we're going to just name it as reshape 3. I don't really have a real connection to what I should call this. This is save as reshape 3. Okay. So the data is ready to go. And we're going to go to analysis now. We're actually going to do the analysis of variance, the ANOVA test. And if we click here, ANOVA is right here, halfway down. We're going to reshape 3. Here it is down here. Now, the response variable, that is our variable that we measured or collected for each salesperson, which it has been called values. When we did the reshape, it called it values. I could have renamed it to something different, but I'm comfortable with the word values. Our factor, the thing that distinguishes group to group, is salesperson. So other than that, I think it's ready to go. There might be some other things we could do here, but I'm fine with just this, and giving it a go. Actually, diagnostics, I'm going to kind of click down there and see what's there. I think I can choose a box plot. I think that's what I want to choose here. Remove these other ones. I want to see a box plot. I like to look at a visual of our data as well as the statistical results. And so here are the results. Let's come down here and look. So we have salespersons 1, 2, and 3. They each have 4 values. This is feeling good. And this ANOVA table here is where I'm going to get the bulk of my information. So we're going to look across for salespersons. We're going to see the F value. This is our F statistic. It's our test statistic here at 0.929, if I kind of round out a few decimal places. And it's really close to 1, which is something that we talked about in the lessons. So I'm not surprised in this next column, this probability greater than F. This is our probability value, our P value, and it's at 0.4299. So the fact that this F statistic is close to 1, it does not surprise me that I have a really large probability value here. Now, before we go write this down and make a decision, let's look at that box plot I wanted. And see, you can see there, this is the data itself. You can see that there seems to be a little bit of a difference here, but the true test of the ANOVA is there a significant difference that we can't say is due to chance, but separately due to the 3 different techniques or sales capabilities of our sales people. So let's go make a decision, but I can see that data here. They do perform a little differently, but is it a significant difference? So let me see if I can remember. I had an F statistic, an F stat of 0.93, and my probability value is equal to 0.4299. So if I put those side by side, I'm a creature of habit. I love to do this every single time, even though I know I just wrote the p-value down. The significance level was dictated to us to be 0.05. So we're going to call our results significant or see that we have unusual results if it falls below 5% or 0.05. And we can see here with our comparison that our probability value at 0.4299 is much greater than 0.05. So our results are not unusual, not enough of an unusual difference to reject the null. So we're going to fail to reject the null hypothesis. So that means we have to keep it. So we're going to keep this null, and the alternative is out of play. So that's the idea here. I do a lot of drawing on top of my hypothesis statements to remind me that the data is indicating that the 3 sales reps there, their means, although they're not perfectly the same, but they're considered equal. They're not significantly different. So that would be our summary statement here. The sample data suggests that there is not, forgot a word there is not a significant difference in the average selling prices that the 3 sales reps have been able to negotiate. I hope that was helpful, and give me a shout if you need some more clarification with this.